Because we are coming to 1.3 slope and intercepts. So let's go ahead and work on the exercise 1.8. So in this section, we mostly gonna talk about slope, and the second one is intercept. And these two actually mostly come from linear relations, right? Which also has the name as like constant rate relations. Okay. So now let's come to exercise 1.8. We're gonna try to complete the table below here first and see what's going on. Okay. We want to convert from feet to inch, right? So I have here 0 feet, gonna be 0 inch. Everyone know that, right? What about 1 feet? 1 feet will be 12 inch. Okay. And so then 2 feet will be 24 inch. Okay, and 3 feet will be 36 inches. And lastly, it's supposed to be 48. Right. So so what did I do to get these number? I mean, you can think that in order to get the to convert from feet to inch, I just multiply 12 with with the number of feet, right? So so now if I thinking what column is input, I would say fit, right? And usually the one in the lab should be the input. Let's say that. Right. And the output will be the second column. So then the output will be inches, right? Okay. So if we want to write a rule to relate inches to feet, could you come up with a rule, right? I just mentioned to you, as you see, in order to get from input to the output, what I do was I just multiply the number of feet with multiply the number of feet with 12 to get the output. So if I say here is the x, then this one going to be y equal to 12x. So I say the rule will be, I'm going to use the function notation as f of x will equal to y and equal to 12x. All right. So now let's go ahead and grab the data. We're gonna grab the data in the graph below where the feet are along the x-axis and inches, and the y along the the inches along the y-axis. So this up. This one, right? So let's we using the tables above and coordinates those points, right? I have in here, let me type it, let me write it for you. So 0, 0 is 1 point, right? 112, and then 224, right? And 336, right? And 448. All right, so now let's go ahead and coordinate those. So first one is 0, 0. Okay. I'm gonna use the other one. So then next one is 112, right? 1 and 12. So 1 for the axis is here. Okay. And 12. So we go up to 12 here. All right. Okay. And then we can have this green one, right? 2 is 24, so this guy. The same thing as 4. And next one, 3 gonna be 36. So we're using the blue one, 36. And 4 will be using pink one. So 4 times 12 is 48. About here. Okay. So we're gonna go ahead and grab it. All right. So here's the grab. Here's the grab bit. Okay. So if I draw this. Okay. Not really good one though. Okay, so I keep that. One more. Okay. Hopefully it's better now. Okay. So now, yeah. So I have equation of the graph of this function is y equal to x, right? Okay. So so I have connect all the point, and I take any point on the graph and form the ratio as output over input. So let's see. So I have output over input. So we're gonna I group adding, I group say accept point 0, 0. Okay. The reason was if you have 0, 0, it's gonna be undefined. So don't use that spot because you put input as 0 at the bottom there, it's gonna be 0. So gonna make undefined. Okay, so accept the point 0, 0. You will. So I'm gonna say typo here. You will have a ratio, let's say choose, let's say I'm gonna choose a point in here. Let's choose 1.5. What do I have for 1.5? This one. This point, what is that? 18, right? It is 1.5 comma 18. So I'm gonna using output over input. So output is 18 divided by input is 1.5. So use calculators, right? And calculate that. So 18 divided by 1.5. All right, what is that gonna be? So if you're using decimals, 18 divided by 1.5 is 12. Okay, so this is 12. Okay, you can use any other point. You don't have to do exactly like me. Okay, you can use for example, like 3.5 here, and what is that? A point over here should be, I know, maybe 42 or something like that. Okay, the answer supposed to be 12. Okay, the ratio is supposed to be 12. Always. Okay, so let's check with the different point, right? So I just make my life easier by using the point 36 3, right? I mean 336. So let's say 336 and what else? 448, right? So let's try that and see if we should have 12. Okay, so I have 36 as output. I divide by 3. What is that equal to? Well, here we go. What about 48 divided by 4? What is that? 12. Here we go. Okay. And again, you can use any other point and you should have the same ratio. Okay. And I mean, it's clearly was the reason is by y equals to 12x there. Okay. So we're gonna move to C, say use a graph to approximate the number of inches corresponding to 3/2 feet and 1/3 feet. So if I use a graph, okay, if I use a graph, so 3/2 supposed to be here, and I estimate it. I would say it's about 42 inch and 1/3, right? 1/3 around here. So I map it. Supposed to be about 16 16 point something. Okay, so I'm just gonna convert it, say about 42 inches, and this is about 16 inches. And again, this is just approximately. You don't have to count exactly number. Okay, I mean, if you want to use, you want to find exact number, you just multiply by 12 for those number. Okay. So okay, now let's move down to talk more about this section. All right. So what did we learn from the column above, right, we have just identified some of the characteristics in linear function. So keep in mind that we in linear function, which is a line, okay, function of a line, function of a line. Okay, we want to connect the concept of rate of change with table values. A graph and an algebraic equations of a linear function. So rate of change, we're gonna talk more about that in the next section. All right. So informally, we use the ideas of rate of change in everyday language, and we back up a steep mountain road, right? So we also have like the pitch of the roof lets the snow fall off, right? Also, the ramp slopes up to the front door, or the highway through the pass has a 6% grade. Then and the floor was titled toward the drain, right? So so the question in here is we can have is, what is the meaning of the italicized word in here? So in mathematics, we call the steepness of steepness or slant of a line is the slope. Okay, let me use other color. Yes, slope. Okay. And the diagrams capture the idea of the slope of a straight line. So, and you see over here is the slope we can count as rise over run, right? So, and you also have learned in correct algebra or sometime in mathematics about slope with rise over run for each linear function. Okay, so let's recalculate the slope of for the conversion from feet to inches down here. Okay. So let's using the way slope will be equal to rise over run. And rise in here, you see that I come from this point to the to let's say from this point come to this point. Okay. What did I do? I did have to rise 24 units to this one, right? To this part over here, right? So 24. And then I run to the right 2 units. Since you see over here as 1 unit was here, and another one is the next one. So to get to the point. So run is 2 units. So then 24 divided by 2, we're gonna give us 12. And the unit for rise in here is, I did rise 24 inches. And for run, I did run 2 feet. So that's the reason why the unit for slope must be 12 inches over feet. Okay. So what does that mean if I want to interpret this? I would say every foot we move to the right equals 12 inches we move up. Okay. So that is a way we calculate the slope. Calculate the slope. Okay. All right. Let's move to the next problem. Okay, so this problem 1.9 over here is similar with the one above. Snail is trying to get to the other side of a park. At what rate is snail traveling? In other words, calculate. So what we do is calculate the slope by choosing 2 points on the graph and finding the rise and the run. So you can choose any point on here and find the rise and run. Make sure includes the unit at feet over minute, right? Okay, so I'm gonna left this for you to go on it. And now we're gonna move to a formula for the slope. I'm gonna use the other color actually. Okay. So you also sometimes will see the formula for the slope as using y2 minus y1 over x2 minus x1, or you can, you can using in another order as y1 minus y2 over x1 minus x2. Basically, you must make the orders be corresponding. So if you consider a line have 2 points, the first point have coordinate as x1, y1, and the second one have coordinate as x2, y2. Then you're gonna have slope as the formula below here. Okay. So let's reuse this formula and we find the slope. Okay. So now let me show you. Okay, so slope gonna be equal to. Okay, so in the left side here, I did have the 2 point coordinate for you guys. Okay, and I also provide is in the given here. Okay, in order to make sure I don't mess up with that, I would like to label on the top of it. Let's say here's x1 is y1 is x2 is y2. Okay, and now I just rewrite the formula of the slope. And I'm gonna use y2 minus y1. And since I'm using y2 minus y1 on the top, then bottom must be using x2 minus x1. And because of that, now I'm gonna just substitute y2 is 2 minus y1 is 4. X2 is 5. X1 is -3. Make sure I minus. So then I supposed to have 5 minus -3 at the bottom. Okay. So let's simplify. Top must be -2. Bottom must be 5 plus 3. And so then I have -2 over 8. That's mean -1/4. Okay, so let's we have we have a box limit. So so what did you notice in here? Notice I have slope is negative, right? So if your slope is negative, what happened with the line? Right? Let me draw it by. Yeah, so so there. All right, so you see now, slope is negative, and you notice that the line is going down. Lines go down from left to right. Right? From left to right. Okay. If you go up a little bit here and see the slope, note that slope is positive. And the line goes up from left to right. All right. And you see that. Okay. So I would like to leave the exercise 1.10 there for you guys to practice on that and put together and draw the graph for me. Okay. So this is a calculate from Teresa, and it could be wrong. Okay, it could be wrong. So watch out that, right? So follow by what I told you and do this one. Okay. I can give you a hint that I'm gonna call you like these two number 2 points. So 3, 7, right? 3, 7. So I have this point here, and then I have 9, 4, 9, 4. Right, and you see now I have a line. I have a line that's going down from left to right. Okay, so that means the slope supposed to be negative. Something was wrong. Okay. Okay. Line goes down from left to right. Okay. So must be negative. Okay, so go ahead and try this. Retry, find slope again and see if it is not doing correct or not. Okay, so now we're gonna move down. Yeah, so I would also list these as the practice for you guys to work on, but I will give you the answer key as slope will be equal to 3. This one gonna be -1/4. This one is zeros. This one is undefined. Okay. For the K that have slope equal to zeros, you will have a horizontal line. And the K, if it is undefined, you will have a vertical line. Okay. So these are things, and the rest you're gonna do it for me. Okay. So we're gonna move down to the next part. So in addition to the slope of a line, we also care about where the line crosses the X and Y axis. These points have special name. So we call X-intercept. And it is the point that the line crossed the axis. And at this point, we have Y value equal to 0. Another one going to be called Y-intercept. And at this point, we have the line cross the Y-axis. And at this point, we have X equal 0. So let's we find the X and Y intercept of the expression of the function 4x minus 3y equals 4 in here. And so in order to find the intercept, okay, so let's do a sidewalk. For the x-intercept, you're gonna set y equals 0. All right. Let me use other spray. So let's say set y equals 0. What happened when you have y equals 0? Okay, so you're gonna have 4x minus 3 times 0 equal to 12. So that means you have 4x equal to 12. And that gives us x equal to 12 divided by 4, which equals. So the x-intercept will be right as the point 3, 0. Okay. The reason was the x value was 3. and the y values was 0. Okay. So I will mark this one as the work. Okay. And the next one, to find the y-intercept, I need the x equals 0. So set x equals 0. And then because of x equals 0, you can right away know that, oh, you have negative 3y equals 0 because 4 times 0 is 0 already. And then you can say, oh, y must also equal 0 since you divide by negative 3 both inside. Okay. Oh, I make a mistake in here, right? It's supposed to be 12 here. Yeah. Sorry. So then, y must be 12 divided by negative 3, which is negative 4. Okay. So then, I have x value equals 0 and y value equal to negative 4. And I will say y-intercept is 0, comma, negative 4. Yeah. All right, so next one. If I have so x minus 0.2y equal 12, and I want to find the x-intercept, y-intercept. So I want to set y equals 0 again, right? And I will have 7x equal 12. So we give us x equal to 12 divided by 7. Right? So then the x-intercept in here will be 12 over 7, comma 0. Right? And for the y-intercept, I have set x equals 0. And I have negative 0.2y. Since the 7x now becomes 0, right? And equal to 12. So then y equal to 12 divided by negative 0.2. I'm gonna have to have more space. So negative 12 divided by 0.2. So I'm gonna have y equal to negative 12 divided by 0.2. You can use the calculators and get negative 60. So then let me highlight it. This guy, this guy, this guy with this guy. So then I have y-intercept will be 0, comma negative 60. Okay. So sometime we can have some different notations for x and y. Instead of that, we can have like p and f of p, something like that. So in here, I have price demand functions as f of p equal to 1720 minus 0.5 p, where p is the price in dollar and f of p is number sold. Okay. I'm going to say number of items sold. Number items sold. So let's find the p intercept and f of p intercept, and the interpretation. So keep in mind that when you try to find the p-intercept, you're gonna set the other the other one to be 0. Similar like when you want to find x-intercept, you set the other value, the other variable is 0, like y equals 0, right? And you find right, right? So in here, you want to find p-intercept, you have to set f of p equals 0. Right? If you set f of p equals 0, okay, f of p equals 0. Okay, so I'm gonna use this. You will have zeros equal to 1720 minus 0.50p, right? And then you will have to move the 1720 to the other hand side. So you can say subtract both hand side by 1720, and you have 0.50p, right? And now you will multiply by -1 both sides. We'll have 1720 equal to 0.5p. Or maybe make it quicker. I would say, make it quicker. I will just gonna do as -1720, and I divide by -0.50, which is p. All right. So then I can have p equal to, so use a calculator and calculate this, and you should have p equal to 3,440. So then the p-intercept will be will be in the order pair. I mean, you can write as 3440 and in dollar, right? On the point in order pair, you can write as 3440, comma 0 for f of p, right? So usually, I mean, always we have input is first, and then after that output to write an order pair, right? So input, comma, input, and input in here is p, and output in here is f of p, something like that. All right. Okay, so what is interpretation in here can be for the p-intercept? Ask me time. I will say, if the price is 3,440, there is no demand. Yeah, there's no demand at all. Yeah. All right. Similarly, in order to find f of p-intercept, which is similar like y-intercept, you will have to set the p equals 0, right? And then find fp. So we have f of p, migrate the function. Let me highlight that function. All right. And then you have 1720 20 minus for 0.5 0 times 0. So that's give us f of p equal to 1,720. So I will say FP intercept is 1,720, or the point is 0,1720. And the interpretations, I would say, if, okay, so when the price is $0 free, right? $0 free. The demand is 1,720. I mean, but actually, it's not really real, but and you can think like, you know, the maximum you can you know provide to all the demand is 1,720 items. So there's no way you have more than that, right? Even if it's free. So all right, so now we're gonna move down, and I also gonna let you work on this exercise and find in the self. In the self, I can give you the answer key. Gonna be answer key gonna be 10 and 0. The second one gonna be gonna be 0, 4. Yeah. Okay, so so we have learned about what we have learned about slope. We have learned about x-intercept and y-intercept. So we're gonna from now we're gonna go ahead and learn about a form of the equations of the line, and with the form name slope intercept form. Keep in mind that it can be written in many equivalent form. Okay. Let me outline it. But I want to introduce slope intercept form, which mostly you're gonna know that was y equal to mx plus b, and the slope is m, and the y-intercept is b. Okay, so if I myself can name this one, I will say slope y-intercept form, because it's provide me the slope and also y-intercept. But anyway, it is someone that filed this form and then state the name was slope intercept form already, so I can't change. Okay, but you can understand that it means that slope and y-intercept. Okay, so now I would like to put the following equation into the slope intercept form. So I'm gonna convert this form here, okay, become slope intercept form. All right. So keep in mind that the slope intercept form has y as being isolated in the left hand side. All right. Okay. So then we can go ahead and try to isolate the y to be alone. Okay. So let's start with moving the 4x to the other hand side. So that's minus 4 both sides. Okay, if I minus 4 both sides, I have negative 3y, and I'm going to have negative 4x plus 12 here. Okay. You can write as 12 minus 4x is okay too, but the thing here is I want to have the 4x first to make sure I have a term of x first. So later I can find the slope m easily. All right. So now I don't want the negative 3 there. So I will go ahead and divide by negative 3 both sides. So I say negative 3y divided by negative 3. And I have negative 4 over negative 3x. And adding with 12 divided by negative 3. Every term divided by negative 3. Okay, because I did divide by negative 3 both sides. So now I have y going to be equal to 4 over 3x. And 12 divided by negative 3 is going to be negative 4. So I put out minus 4 here. Okay. So that means what? I mean, I have two things in here. I have slope, and I also have the y-intercept. So m equal to 4 thirds. Y-intercept will be equal to negative 4. Okay. Or 0 and negative 4 as a point in order pair. Okay. Similarly, for the actually, but I forgot to state the answer. The answer must be here. Oh, yeah. That is slope intercept form. Okay. So now if you go to part B and I say I want to convert to this to slope intercept form, well, you can see it's almost there already. You just need to you didn't isolate the f of p already. You just need to make the p term is before the constant term. So I just move only these two and to be like f of p equal to negative 0.50p and adding with 1/720. And as you see here, slope is, I mean, this is done already. It is answer already. And you can just like, you can notice that slope m equal to -0.5. And the y-intercept in here is equal to 1720. Or you can write as 0.172. All right. So according to the information, I mean the problem above here, you can go ahead and try to find the slope and the y-intercept according to the linear equation in form of slope intercept form here. Okay. Keep in mind that sometimes if you don't see clearly, for example, y equal to 3, 4 x here, you can convert it to be like plus 0. Right? Try to make is exactly like the form, so you can get it. Okay. So the first one, slope must be 4, right? Second one, slope gonna be 3, 4. Third one gonna be -1. And you see that, right? And the y-intercept for the first one is 5. Y-intercept for the second one is 0. And the last one gonna be -6. Okay. You can also write it in a other pair you like. Okay. I'm gonna stop this section 1.3 here. And what we did learn in this section is how to find slope and how to find y-intercept. Oh, actually y-intercept. Like that. All right, I see you in next section.